Welcome to the Deep Dive, your shortcut to getting up to speed. Today we're jumping into something called human-computer interaction, or HCI. We've dug through a whole bunch of sources to sort of unpack the secrets behind tech that just works.
Right. This is all about understanding how computers or systems are designed ideally to think like you.
So what is HCI, fundamentally?
Well, at its heart, it's about designing and studying how people, interact with computers. The big focus is usability, efficiency, and honestly, user satisfaction. Does it feel good to use?
Okay.
And what's really fascinating, I think, is how it pulls from so many different fields. You've got computer science, sure, but also psychology, design, even ergonomics.
So things like an ATM interface, or just how my phone works?
Exactly. Those relatively clear ATA screens, the way you swipe and tap on your smartphone, maybe your car's navigation, that ease of use, that's HCI in action.
Okay, so if we boil it down, what are the main goals? What's HCI trying to achieve for us users?
Well, the biggest one is making systems intuitive, easy to learn, easy to use. That's usability.
Right.
It's also pushing for what we call user-centric design, basically making the computer behave in ways you'd expect, so there's less friction, less guesswork.
Reducing confusion?
Precisely. Reducing those barriers between what you want to do and how the system actually lets you do it. Think about airplane cockpits. They used to be incredibly complex.
Oh yeah, walls of dials.
Right. And now you see these sleek, intuitive digital dashboards. That's years of HCI work, constantly refining for the human pilot.
That makes sense. Okay, let's dig into the human part of HCI then, because, we're half the equation. Our sources really emphasize how our brains process things during these interactions.
Totally. Our senses are the input channels, right? Vision for reading screens, hearing for sounds or alerts, touch for keyboards, mice, touch screens.
Haptic feedback too sometimes?
Yeah, haptic feedback. And then our actions typing, pointing with a mouse, gestures, those are our outputs to the system. And the key thing is, interfaces have to respect our human limits. Sensory limits, motor limits.
Like font size you can actually read, or buttons spaced far enough apart.
Exactly. Or think about using a mouse. You move it, you instantly see the pointer react, you click. It's a very rapid feedback loop designed around how quickly we can process that cause and effect.
Okay, and what about memory? That seems like a huge factor. Any big memory trap designers try to deal with?
Oh, definitely. Our short-term or working memory is surprisingly limited. You know that 7 plus or minus 2 rule? It's kind of hard to juggle more than a few new things at once.
Like trying to remember a phone number someone just told you.
Right. Gone in seconds if you don't rehearse it. That's why designers lean heavily on recognition over recall. It's just easier for us to recognize an icon or a menu option than to recall some specific command we need to type out.
Ah, so menus and icons versus like old command line stuff.
Pretty much. And things like consistent layouts, familiar icons, visual cues, they help tap into our long-term memory, making systems feel predictable and easier to navigate over time.
And what about our thinking when we're actively trying to solve a problem using the tech?
Yeah, designers know we're constantly trying to make sense of things, look for patterns, maybe have those little aha moments where something clicks.
Right.
So features like, say, autocomplete in a search bar. It's not just saving you typing, it's actually assisting your reasoning process by predicting what you might want, reducing the effort. It feels like the system is meeting you halfway.
Okay, so that covers the human side. But computers have their own issues, right? Delays, limits. How do designers bridge that gap?
They absolutely do. Computers aren't instantaneous. You get system delays, graphics might lag, network connections can be slow.
The spinning wheel of doom.
Exactly. And a really crucial design principle here is always give feedback. That loading bar, the progress spinner, when you upload something, it tells you, okay, I'm working on it. Even if it's taking a moment, it manages expectations.
That leads into something our sources mentioned, these gulfs in interaction.
Yeah.
Norman's model.
Yes. Don Norman's execution evaluation cycle. He identified 2 key gaps, or gulfs. First is the gulf of execution. That's the gap between what you intend to do and what the system actually allows you to do. Can you figure out how to make it happen?
Okay.
Then there's the gulf of evaluation. That's about understanding the system's response. Did it do what you wanted? Can you tell what state it's in now?
Like the classic error 404. Tells you something went wrong, but not really what or why.
Precisely. That kind of vague message creates a huge gulf of evaluation. It's frustrating because you don't know what to do next. Good design uses clear messages, obvious feedback, consistent responses to bridge both those gulfs.
So considering all this, human limits, computer limits, bridging the gulfs, What are the main ways we actually do interact with systems, the different styles?
Well, there are several main styles. You've got command line interfaces, think Linux terminal, super powerful for experts who know the commands, but steep learning curve.
Right, requires recall?
Then menu-driven interfaces, like most smartphone apps. Very intuitive for beginners because it relies on recognition. You see your options.
Okay.
Form fills, like filling out an online registration. Structured, guides you through inputting specific info. Direct manipulation is a big one. GUIs like Windows or Mac OS, where you can, drag and drop files, click on icons directly.
Very visual.
Very visual, feels like you're interacting with the objects themselves. And increasingly, natural language, talking to Siri or Alexa, or typing questions into a search engine, trying to make it feel like a conversation. Each style has its place, depending on the task and the user.
So, wrapping this up, what's the big picture here? The main takeaway?
I think it's that good HCI is this really skillful blend of understanding people, our psychology, our physical limits with understanding computing, and applying smart design principles.
It's about making things easier for us mentally.
Yeah, reducing that cognitive load, giving clear feedback, picking the right tool, the right interaction style for the job. Ultimately, it's about building technology that's usable, efficient, and hopefully even enjoyable, tech that serves human needs.
Absolutely. So, maybe a final thought for everyone listening?
Sure. The next time you use any piece of tech, your thermostat, some software at work, whatever, just take a second. Try to notice that invisible layer of design. How much of it was shaped by thinking about your memory, your senses, even those little aha moments. It's this constant invisible dance between us and the machine happening right there. It's pretty cool when you start to see it.